I'm going to discuss Cohen Sutherland line clipping algorithm, and now let's look at this Cohen Sutherland line clipping algorithm in C. In order to discuss the algorithm, I'm going to use a C programming code. Okay, so now let's look at the code. The first line of code, for the time being, let's ignore this one. Later I will come to this line of code. Now let's look at the second line of code. Okay, now here we have define round. The parameter is a, and here we have int a plus 0.5. Okay, so the purpose of this function is to round a floating point number, any number to its nearest integer. For an example, if we pass 3.7 as a, nearest integer is 4. Okay, if we pass 7.631, nearest integer is 8. Okay, if we pass 10.2, the nearest integer is 10. And what happens if you pass 14.5? Okay, in mathematics usually nearest integer to 14.5 it is 15. Okay, so that is the purpose of this function, rounding the passed number to its nearest integer. Now let's see how it's going to happen. Now let's say if we have a particular number 5.61, okay, we pass this one as a, then here what happens, 0.1 will be added, 0.5 will be added, 0.5. then the answer is this one, and here we typecast using this one. That means in this number only integer part will be taken, fractional part, the decimal part will be discarded, this part will be discarded, and now therefore this becomes 6. That means what has happened, now this is our a, okay, now this has become 6. Here what has happened, rounding. Okay, we have rounded this number to its nearest integer, and then this one can be explained in this way. So if you have, this is the real line, and if we have 3 and 4 here, okay, two numbers, then at the middle we have 3.5, and let's see. So now you know, if you have a number somewhere here, okay, if we have a number somewhere here, in this position we have a number, then what happens when we add 0.5 to this number, we add 0.5. 0.5 means this much of amount, no? So if we add that amount, this number goes here. This is our new position. So it is less than 4, no? Therefore, if we discard the fractional part, what happens? It will become 3. Okay. Therefore, in this way you can understand any number less than 3.5. Any number less than 3.5, if we add 0.5, it will be in between these two. Okay, in between these two, and when we discard the fractional part, it becomes 3. Okay, then what happens? If we take 3.5, then if we add 0.5, it is going to become 4, and if 4 means if we typecast, it is 4. Okay, therefore 3.5 becomes 4. Okay, now let's see if we add the number somewhere here. Okay, somewhere here, and we add to this number, we add 0.5. 0.5 means amount equal to this length, no? So it will come to somewhere here. Okay, 4 point something. The number will become 4 point something. And when we typecast, the fractional part will be discarded and 4 will be taken. So any number in between these two will become 4 point something if we add 0.5. Okay, and when we typecast, the fractional part will be discarded and integer part will be taken. Okay, in that way, logically you have to understand, to any fractional number, if we add 0.5, okay, if we add 0.5 and then we discard its fractional part, then this number will be rounded to its nearest integer. In that way, logically try to understand this. Okay, now let's move to next line of code. Okay, so before that, now you can see left edge, right edge, bottom edge, okay, bottom edge, top edge. Likewise, 4 variables we have defined. Actually, now when we consider Cohen Sutherland line clipping algorithm, so we clip line segments against a rectangular window. Okay, that means if our input is this line segment, the algorithm should be able to extract the part inside the rectangle. Okay, if our line segment is this one, then the algorithm should be able to extract the part inside the rectangle. Okay, so anyway, so if our line segment is like this, okay, then nothing will happen to the line segment after executing the algorithm. Then if the line segment is outside the rectangle, so it will be ignored. Okay, in that way, in Cohen-Sutherland line clipping algorithm, we use a rectangular window. There, any line segment, when it is passed to the algorithm, any line segment we should be able to extract the part inside the rectangle. Okay, that is the purpose of Cohen-Sutherland line flipping algorithm. Actually, doing this task is not difficult. If you know some programming, you can do this. Okay, but the challenge is to do it efficiently. Okay. That is why we have a complicated algorithm like this. We have to think about the time of execution, okay, time taken for execution. Otherwise, doing this task is very simple. You can write a simple code to do this task. And now here we have a rectangle, and there we can extend. Now rectangle here, now let's say this is our axis, x and y, and this one is parallel to x axis and this one is parallel to y axis, and here this one extended left edge we extend, okay, extend, and this one we call it left edge, and this one we extend in both directions. This one actually bottom, yes, I do not have enough space for the time being. Let's erase this one, and yes, this one, it is our bottom edge, and if we extend this one, this is our top edge. Okay, now we define 4 variables like this. We define 4 variables, and here left edge is left edge, that is 0 x 1. This one is 0 x 2. This one is 0 x 4, 0 x 8. Okay, now the representation, this one in C programming we represent, this is actually, these are numbers. So 0 x 1 means if we convert 0 x 1, okay, here 1, if we convert this to binary, so you have this one, okay. 0 x 2 means you have this one, okay. 0 x 4 means you have 0 1. 0 x 8 means you have, you have 1 0 0 0. Okay, so this is the corresponding, these are the corresponding binary number. Okay, so actually we can understand this as 0 0 0 1 means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, so if we convert this now 8 into 0 0 plus 4 into 0 0 plus 2 into 0 0 plus 1 into 1 1. Here you get 1. Okay, you get 1. You get 1. Therefore, we can represent it in our program in this way, 1. Okay, in the same way, now you can think about 0 0 1 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and here 8 to 0 0, 4 to 0 0, 2 to 1 1, 1 to 0 0. Sorry, 2 to 1 is 2. Okay, 2 to 1 is 2. And now here we have 2. Therefore, we represent it like 0x2. And similarly, you can decide that 0, 1, 2, 3. 8 into 0, 0 plus 4 into 1, 4. 2 into 0, 0. 1 into 0, 0, 4. And therefore, we represent is 0x4. Okay. In the same way, the last one. Okay, obvious thing. So, we have 2 to 0, 2 to 1, 2 to 2, 2 to 3. Here 8. 8 into 1, 8. 4 into 0, 0. 2 into 0, 0. 1 into 0, 0, 8. Therefore, we write it like 0x8. Okay, in that way you have to understand. Now, we will be working with this 4-bit binary codes. Okay, left edge. Now, left edge has a binary code. Right edge has a binary code, bottom edge and top edge. Okay, we have binary code. So okay, so now now let's move to the next function. Define inside we have the exclamation mark A. Okay, so the purpose of this one is now this is the not operator, something like that, not operator. Okay, so that means if we pass all zeros here, now for this one, I told you that we will be working with 4-bit binary codes. If we pass this one here, its negation, if we negate it, this is going to return a number which is not 0. Okay, a number which is not 0. Non-zero value will be returned. Okay. If we pass all zeros, non-zero value will be returned. If we pass some non-zero value, then this will return 0. In this situation, if we pass all zeros, non-zero value will be returned. If we pass a non-zero value, 0 will be returned. Okay, that is how this function works. Okay, it is negating. Negating means if we pass 0, it will return a non-zero value. If we pass non-zero value, it will return a 0. Okay, in that way it works. Okay, so now let's move to the next function. So we have define, okay, define, reject a comma b. We have two parameters, and here a ampersand symbol b. Okay, this operator we call this bitwise and operator. Okay, I hope you are aware about AND operator. This is the symbol, and here you have it like this. Okay, so if you have x, y, and here output is z. Okay, so x, y, z. Now let's say we have 0, 0, 1, 1, 0, 1, 0, 1. Those are the possible combinations. And AND operator means if we have here 0, x, y, if both are 0, we get 0. Okay. If one particular one is 0, we get 0. If both are 1, then only we get 1. Okay. Here 0 means false, 1 means true. Okay, that is our AND operator. Okay, bitwise AND means bit by bit. For an example, if we pass our A value, if we pass 0, 1, 0, 1. For the B value, we pass 1, 0, 0, 1. Okay, now if we perform bitwise AND operator, that means bit by bit. These two, 1, 1, we get 1. Then these two, we get 0. These two, we get 0. These two, we get 0. Okay, that is the meaning of bitwise AND operator. Okay, then let's move to the next line of code. Hash define accept a comma b. Here we have not operator a or b. O means this one, the name of this one is bitwise O operator. Okay, bitwise O. Now O operator, this is the symbol x, y, z. Now we have x, y, z. Again our table. Zero, zero, 1, 1, 0, 1, 0, 1. Okay. Then O means both 0, 0. Here 1, 1, 1. Okay. This is our O operator. Now bitwise means, as in earlier situation, bit by bit. Now our A is, let's say, 0, 1, 0, 0. Our B 1, 1, 1, 0. Okay. Then bitwise O means 0, 0. We get 0, 0, 1. We get 1, 1, 1. We get 1, 0, 1. We get 1. And now again, that is the output of this part. Then we have not operator. That means now this situation, it is a non-zero value. So this function will return 0. Okay, this function will return 0. We have a non-zero value here. Therefore, this will return 0. Okay, so in that way, we have discussed up to this, and now let's again look at our algorithm. Now this is a function, encode function. Okay. Likewise, we have function, another swap PTS, another function, swap codes, another function. Okay. Then this is what we should execute. Okay, clip CS function. Clip CS function. Okay. Now again, let's see if this is our rectangle. This is our rectangle, and now we have x-axis here, y-axis here, and here we have the origin. Okay, this is our rectangle. This one actually, this edge is parallel to the y-axis, and this edge is parallel to the x-axis. And now here, if we extend this, now this coordinate we call it min x. Okay, and if we extend this coordinate max x, if we extend this coordinate min y, if we extend this coordinate max y. Okay, in that way we have four values. Four values we have, and the line segment. Now we have a line segment now as the input. Now input to our algorithm, we have to provide these four values. Okay, these four values will define the rectangular window of our algorithm, and then the other input is the line segment. They are here in this code. In this particular code, I use two arrays. Okay, so here x0, y0, one particular coordinate. Here x1, y1, that is the other coordinate. Okay, so and now double value, if we want to store a line segment. So this is how this is how we do inside our main function. Inside our main function, let's say we have a then we have to declare double min x, double min x, max x, double min y, double max y. Okay, in that way, let's think here we have 100 and here we have 700. Okay, values. This value is 100, this value is 700, and this value is 300. And this value is 500. Likewise, we can assign values. And then let's see now. Since I do not have space, what I should write like this, I will write here. Okay, so now let's say double x2, double y2. In that way, you have to declare two arrays. The purpose is here. Let's two arrays. Now in our line segment, we have two endpoints. Let's say 0 and 1. Okay, in indices. Here we have x0, y0. Okay, x0, y0. Here we have x1, y1. Okay, in that way we have these coordinates. And let's say this coordinate is 400, 500, and this coordinate is 200, 600, something like this. Okay, in order to store this particular line segment, what we should do? To x0, this is our x0, it is 400. Okay, it is 400. Now this is our y0, 0 endpoint, no? So here it is 500. This is our x1, it is our 200. This is our y1, it is our 600. Okay, now if you look at this as an array, now this is our array x and this is our array y. In x we have two values, these are the indices, two values, these are the indices. In x0 cell we store 400 and x1 cell we store 200. X1 so y, yes, y0 500, y1 600. Okay, now in two arrays we store the 4 coordinate values. Okay, so in that way we can store our line segment and these values of the edges. Okay, and now what we should do is these values. Okay, with these values, what you do? All these things we do inside the main method. Okay. Now, as I have discussed earlier, okay, inside the main method, we have done what I had discussed earlier. We assign values to min x, max x, min y, max y, and also to x array and y array. We have assigned values. After that, we can invoke this function. Okay, this function, and we pass x, y, okay, xy, min x, min y, y, max x, max y. Okay, in this way, inside the main method, we invoke this particular function. Okay, now that is what we do. Okay, then let's look at this clipcs function. So we declare, first we declare unsigned char, code 1 and code 2. Two values. Okay, so we use unsigned char. Okay, in order to store code 1 and code 2. Two variables. Okay, so actually our purpose is to deal with 4-bit binary codes. Okay, in order to store them, we use unsigned char data type. And now here, initially done and draw variables, we set them to 0. Okay, done and draw variables, initially we set them to 0. Okay, let's discuss, I will explain the purpose of these variables later. And we have another variable double m. The purpose of this m is to store the gradient of the line segment. Okay, gradient means what do you understand by the gradient? We have the line segment, and here we have x1, y1, x2, y2. Gradient means y1 minus y2, x1 minus x2. Actually, this is not defined in every type. In a situation like this, if our line segment is parallel to y-axis, then these two values are x1, this value is 0, no? Then here we have division by 0. In mathematics, you know that dividing 0 is indeterminate. Division by 0 is an indeterminate form. So in situations where x1 not equal to x2, in that situation we define the gradient m. Okay, so now that's little about the variables. Now we have a loop. While we have a loop, and here initially done, we check whether done variable is 0. We have set it to 0, so first time it gets executed. Okay, then then code 1 and code 2 we invoke encode function. Okay, likewise then you can see accept function, reject, inside, swap PTS, swap codes, left edge variable, right edge variable, bottom edge, top edge. Okay, likewise then we have conditional logic here. We check whether draw is 1. Okay, that means here we had a while loop. While loop is started here. This is the opening brace, and this is the end. Okay, while done 0, we have something here happening inside the while loop. Okay, so using a loop we prune the line segment. Okay, then after that we check whether the draw variable has become 1. If so, we set color means we set color. Actually here in C programming 15 means white. Okay, 15 means white. So we set the color of the line segment to white, and after that we use this line function. Okay, and line function, and then to the line function we pass for coordinate values. Okay, we have line function. To this line function we round. That means we round x naught, then we round y naught, then we round x1, then we round y1. Okay, in this way we invoke this. This is actually here we are using graphics. Okay, so we pass now in our graphics screen. Here we have integer coordinates in this direction and this direction. We have integer coordinates, so we have to always pass. Yes. Okay, we have to always pass integer values. Okay, that is why, and here we use round function and round this number to its nearest integer. Okay, in that way we can draw the clipped line segment in a more accurate way since we round. Okay, and now this line function, in order to import this line function to our program, then let's go to the very beginning of our code. Now I told you at the very beginning I just ignored this line of code. Actually this will import necessary header files that contain line function. Okay, that was the purpose of this line of code. Okay, now we have discussed all these things. Okay, and Encode function we did not discuss, so nothing other than the initial part we have not discussed yet. So the best way to teach Cohen-Sutherland algorithm is to use an example. Okay, so I am going to use the best way. Now this is here, you cannot see this one, but don't worry, these two files you can find. Okay, so if you go to this link in my academia profile, you can find this Cohen-Sutherland line flipping algorithm in C code, and as well as this example document you can find in my academia profile. Okay, so now let's try to understand the algorithm using an example. The problem: demonstrate how Cohen-Sutherland algorithm works for the line segment shown in the following figure. Note that it intersects only with right and top boundaries. Yes. Now we have our rectangle is this one. This is our rectangular window. So we can extend it. We can extend it in this direction and this direction, here, this direction and this direction, this one here, this one here, this one here, this one here. Okay, in that way. Now we have a line segment. Some of yes, here you have the line segment, and this is our 1 and this is our 0. Okay, I just represent using the indices. This is our 0th endpoint and this is first endpoint, let's say like that. And now in our answer, yes, in this way we have represented. Now what happens? Now inside the main method what we do? Inside the main method what we do? We invoke clipcs function. Clipcs function. Let's go back to our algorithm, and here clipcs function, there we pass x value, y value, then min x, min y, max x, max y. In main method we invoke this clipcs function, and after that then execution begins. Okay, execution begins. So we declare to code 1 and code 2 two unsigned char variables. Then we declare two integer variables, done and draw. Then initialize them to 0. Then another double variable, and now we have the while loop. Okay, initially. Now in the example I have shown it. Initially done variable, it is initially 0. Draw variable, it is initially 0. Okay, now again you have to go back to the code and find the corresponding line of code. This one here in the example I have shown it like this. And now we move. So after declaring these these variables, we move to here while done equals 0. Now if you check this condition, done this condition is true. Understood? This condition is true. This condition is true. Therefore, the code inside the while block will be executed. And now here what we do is to the code 1 variable, we assign a value after passing x naught and y naught, min x, min y, max x, max y values to encode function. Okay, now it's the time to explain encode function. Okay, so now let's go to the encode function. Okay, now here we get here, if you look at here, so x naught and y naught, and here what we do is to the encode function we I will write down this here. Code 1 we invoke encode function here, x0 y0, okay, x0 y0, min x, min y, max x, max y, okay, max y. Now in this way you invoke, and now if you look at the encode function, okay, now let's look at the encode function. There what we do, that function return unsigned char value. That means a 4-bit binary code we can return from this. Okay, at the beginning we declare 0x00. Okay, that means initially code value is this one. Okay, in order to understand this one, we represent in our programming code like this. Okay, so this is this 4-bit binary code. In our programming code we should represent it like this. Okay, and now we execute a particular code. Now here if x less than min x, if x less than min x, we have to check the condition here in this example. So first we try to find code 1 value, no? Code 1 value. Okay, here when we execute this line of code, we are going to find the value of code 1, and now initially code 1 code value is initially 0. Okay, if you look at this code value, now code 1 value, when code value will be all zeros, and now what we check inside, x less than min x, x less than min x. Now this coordinate we have sent, no? This x less than min x is x0 less than min x. Okay, this is our let's write down. Here we have max x, here we have min x, here we have min y, here we have max y. Okay, so now min x, x0, it is not less than min x. Okay, min x, and here you can see therefore false. Here this condition is false. Condition is false. And now, therefore this line of code will not be executed. Okay, then it comes to this part and check whether x greater than max x, that one greater than max x, x naught greater than max x, no, that condition is also false. Okay, here this condition is also false, this line of code will not be executed. Then it comes to this part. Okay, that is why I have shown it here. Y less than min y. Does y value less than min y? No, it is false. It is false. Then after that, therefore this line of code will not be executed, and if y value, then therefore here it is false. Then again we check whether the value of y greater than max y, whether this condition is true, greater than max y. This is greater than max y. Y naught value greater than max y, therefore this is true. No, this condition is true. Therefore this line of code will be executed. Now can you remember the codes? Left edge, right edge, and what are the codes? Okay, so I will go to the top of our code, and here left edge, you know, left edge means 0x1, that means 0 0 0 1. Okay, this was right edge was 0x2. Okay, therefore 0 0 1 0, okay, this edge, okay, right edge, left edge, right edge, then bottom edge 0x 4. 4 means 0 1 0 0. Yes, here let's put an arrow. This one 0x8 1 0 0 0. Okay, that is our top edge. And now bottom edge and top edges. Now let's go there. Okay, this line of code will be executed. That means yes, I will write here, then code in O top page, bitwise O top page. That means our code value initially it was 0. Okay, initial value was 0 0 O. Now our new code value is 0 bitwise O top page. Top page code means this one. If you bitwise O, you can understand it will be like this. Okay, so our new code value will be 1 0 0. Okay, this is the value of our code, and that value will be returned. Therefore, here we have in the example document I have shown it like this. Code we should assign to the code bitwise or top edge. That means initial code that was all zeros, or top edge means this one, and now we have this. Okay, so this is this value will be returned. Therefore, code 1 value will be 1000. Okay, this is our code 1 value. Okay, so this up to this part we have explained what happens when we execute this one, this line of code. When we execute this line of code, what happens? Then we move to encode function, and inside that initially the code value was 0 and this was false. Therefore, this line of code was not did not execute. This condition is false. This line of code did not execute. This condition is false. This line of code did not execute, but this condition was true, and therefore this line of code was executed, and therefore we return that after execution we return that value. Now our code 1 is this. Okay, so after that, now after the execution of execution of this line of code, then we move to this one, code 2. We try to code 2 here, 1 1. Code 2. Okay, so I will erase this part. Code 2 in here in the example I have shown code 2 with this endpoint we execute encode function with respect to this endpoint, and now here let's go to our encode function, and initially code value is 0. Okay, then we check this condition, x less than min x coordinate of this point less than min x. No, this one is false. X greater than max x, yes, max x greater than, this condition is true. This condition is true, therefore this line of code, now earlier this condition was false. Okay, therefore this line of code did not execute, but this condition is true, therefore this line of code is executed. Okay, so now our code value new code value, that is initially 0 or right edge means this one's 0 0 1 0 and this one 0 0 1 0. Okay, that is our code value. Then again yes, now if you look at the example you will see yes, this one, then this one, this one. Then we move to next part, y less than min y, y coordinate less than min y. No, this is false. Y greater than max y. No, y coordinate greater than max y, that condition is also false. Therefore now we this condition is false, therefore this line of code is not executed, and this condition is false, therefore this line of code is not executed, and now the value of code is returned. Now therefore our code 2 value is 0 0 1 0 0 0 1 0. Okay, okay, now we have finished discussing the execution of this line of code and this line of code. Okay, after execution of yes, after execution of this line of code, then code 1 value becomes what? Code 1 value became okay. Then after execution of this line of code, code 2 value became 0 0 1 0. Okay, then after that in our programming code we check this condition, accept. We invoke accept function. There to the accept function we pass code 1 comma code 2. Okay, when we pass code 1 comma code 2, what is our accept function? This one, okay, this one, then not operator 1 0 0 0 or 0 0 1 0, not operator, then O 1 0 1 0. Okay, this value, then that value, so this is a non-zero value, so it returns a 0 value. Okay, 0 value, therefore let's say false. Our condition is false. Okay, here now condition is false because now this is a non-zero value, this returns a 0 value. That means in our C programming, inside this parenthesis, if you put 0, then the corresponding block will not be executed. Okay, that is C programming. Okay, so if we put here a non-zero value, any value other than 0, 5 or minus 1 or any value other than 0, okay, 5, then the code, the block will be executed. Okay, therefore in this situation I have simply shown this is false because now the condition is false in this situation, and therefore this block will not be executed. Okay, then it comes to, yes, yes, this one false, then it come here, reject. Code 1, code 1, code 2. Then let's look at our reject function. A and B. Here 1 0 0 0, bitwise and operator 0 0 1 0 0 0 0 0, all zeros you get. Then let's say this is false, a zero value, no, so the block will not be executed. This block will not be executed, and here we can see it is false. Then we can see it is false. Then we move to the next part in the code, else if. Here if, and this condition was false, we came else if part and check this condition, it is also false. Then we come to this block, else block. Then here another condition, we check inside code 1, inside code 1, inside code 1. Now let's look at our inside function. Okay, they are not a. Code 1 means 1, this one. Now here we have a non-zero value, therefore it returns a zero value, therefore this also false. This one is also false. Okay, it is also false. Therefore this condition is this block will not be executed. The condition is false now. This block will not be executed, and then it comes here. It checks the condition x0 not equals to x1. It checks this condition. This condition, x0 and x1, they are not equal. The condition is true because this checks whether the line segment is not parallel to the y-axis. Okay, because we are going to compute the gradient. If we want to compute the gradient, and if we want to have the gradient defined, gradient should be determinate. In that situation we check this condition. That is the purpose. Okay, this condition is true, therefore we compute the gradient. Okay, so in the example I have shown it like this. So we compute the gradient. How How we compute the gradient? Y1 we subtract y0, then divide x1 x0. Okay, then that is how we computed the gradient, and then we move to this one. Okay, then I will erase this part. I will erase. Okay, still our code values are this, they did not change. Okay, so I will keep these two lines and erase the rest. Then here we check the condition. Code 1 bitwise and left edge. Code 1 means 1000 ampersand. Left edge means this one 0001. Bitwise and 0000, all zeros. You got all zeros. Okay, you got all zeros. Therefore, let's say it is false. Therefore, if we put this value to our inside our if block, it is a 0 value, therefore it is 0, therefore this block will not be executed. And then else if this part it comes to this part, code 1 right edge. Here code 1 means, now right edge means 0010, 0000, all zeros. This is also false. Okay, this is also false, therefore this line of code is not executed. Then it comes here. Now let's look at this here. Yes, these two parts we have discussed, and then we move to the this one, code 1 bitwise and bottom edge. Okay, bottom edge. Then code 1 means 1000. Bottom edge means 0100, this value bottom edge. Then 0000, all zeros we get. Let's say all zeros means false. Okay, then this block will not be executed, and then it comes here. Code 1 top edge. Code 1 means 100. Top edge means 1000. Okay. In this situation, 1 bitwise 1, other zeros. Therefore, here we can say this is true. This is a non-zero value. Therefore, this block will be executed. Okay. Again, it checks the condition. Now, let's say Yes, this part we have discussed. Then this part again it checks the condition. This one x naught not equals x1. That means the line segment is not, this is true, x naught and x1 they are not equal. That means the line segment is not parallel to the y axis. This is true. Okay, so this is true, therefore this one I will explain this. This two will be executed. Okay. Okay. Then before that, I will erase this part in order to explain. I will erase this part. Let's keep this two as it is because those values didn't change. Okay. And now let's see, this is our rectangle, and here with the, so this is our, this value is max y value. Okay, now we have our 0 1 line segment. Okay, in this situation we are going to compute this intersection point. Okay, that's what we have done here. Okay, let's see how we do that. Okay, now gradient m we had already computed. The gradient of this line we had already computed, and therefore the equation of the line we can write y, we subtract y naught because we know two coordinates, and x naught, this equals to m. Okay, then we can write it like this: x naught, that is equal to y minus y naught we divide by m. Okay, now again we can write this x naught plus y minus y naught we divide it by m. Okay, now this one, now this is the equation of this line. Okay, not the line segment, actually the equation of the line. Okay, then if we put y equals max xy, if we substitute here. Okay, if we substitute, because y coordinate is max y, we substitute it here to compute the x coordinate. Now x coordinate we can get x naught plus max y minus y naught we divide by m. Okay, now we use the same variable. Okay, to the same x naught we are assigning the value. Therefore in this way we can do that. No, if we are using the same variable x0 plus max y minus y0, that's because we are assigning the value to the same variable. Okay, so this can be written in abbreviated form using this operator. Okay, and now that is the x coordinate. Now y coordinate is y0 is max y. Okay, max y. Y coordinate is max y. This is the x coordinate and y coordinate is max y. Okay, likewise we have computed, and now our new now x0 and y0 values are here. Okay, now our line segment x0 and y0, they are here. They are here. Okay, so in the example I have shown it like this. Okay, now we have come to the end of our while loop, and again we go to the beginning. We check, yes, I erase this part. Okay, then again we come to here. We check the condition done. We did nothing to this done variable, no? Therefore, it is still true. Okay, so since the condition is true, we come to here. Okay, we come to here. Code 1. Code 1. So we invoke the encode function using 0. This one, using this one, we invoke encode function. Let's look at the encode function. Okay, encode function with respect to this 0. Okay, then initially code value is 0. Code value is 0. Then we check x less than min x. This condition we check x less than min x. X coordinate less than min x. No, it's false. Okay, it's false. This line of code is not executed. Then we check the condition x greater than max x. No, x coordinate is not greater than max x, it is false. Then y less than min y. Y less than min y. Okay, not less than min y, this is false. Y greater than max y. What is the answer? Now earlier this y coordinate we assigned to the y coordinate max y value. Now y coordinate equals to max y. Therefore it is not greater than max y. Okay, therefore this condition is also false. Therefore our code 1 value remains as it is. Okay, so this one false. This line of code was not executed. This condition is false. This line of code was not executed. This one is false. This line of code was not executed. This one is false. This one was not executed. Therefore, we return the previous value. Yes. Now this one. Okay. Now these values. Yes. Now code 1. Code 1 value becomes all zeros. Okay, so these values are invalid now. Okay, because invalid because we are executing a new execution of encode encode function. Okay, so here not invalid. Yes, previous values were there because here to the yes. What were the previous values? Yes, they were there. Code 1. Code 2. 0010. Those are the two values we had earlier in earlier situation. This one and this one, no? And if you look at here in our clip.cs function, these two are local variables. Still now we have the previous values, and now once we return new value, so this value will be replaced to this. Okay, this one remain as it is. Our yes, okay, now we move. Now this line was this line of code was executed. Then we move to the next line of code, this one. Okay, so code 2. Okay, then here with the encode function with this one, we invoke encode function passing coordinates of this endpoint. Okay, now let's look at the encode function. There initially our code value is 0. Then x less than min x, this condition is false. Then x greater than max x, this condition is true. To the max x, condition is true. Okay, condition is true. Now this this line of code will be executed. Okay, then that means code to the code we assign all zeros or right edge. Right edge means 0 0 1 0 0 0 1 0. We put the operator. No, therefore here we have this one. Okay, 0 0 1 0. Zero zero 1 0. Here we have. Now let's yes, this one. Then again we move to here, y less than min y. Y coordinate, it is not less than min y. This is false. Y greater than max y. This is false. Okay, not greater than max y. Okay, this is false. Therefore, now we come yes, less than min y. This condition is false. This line of code was not executed. This condition is false. This line of code was not executed. Now we return code. That means code we return. Now our code value is this one. Okay. Therefore, code 2 means 0 0 1 0. 1 0, we get the same previous value. Okay, same previous value we get because this point did not change. Understood? That is why we get the same previous value. Anyway, the same value will be replaced by the same value, because in a program it again assigns the same value to the variable. Okay, now these are two values. Code 1 corresponds to this one. It is all zeros. Code 2 corresponds to this one. The value is this one. Those are the now code 1 and code 2 values. Okay, now after that we have invoked to encode functions. Okay, then after that we move to this one, accept. We have code 1 comma code 2. Meaning of this one is what? Our accept function not 0 0 0 or 0 0 1 0, not operator, no, 0 0 1 0. Non-zero value therefore returns 0, that means false. The non-zero value this one. Then here since it is false, this block is not executed, then it comes here, reject code 1 code 2. Okay, then reject function, that one, 0 0 0 0 0 0 1 0, bitwise AND operator, therefore we have all zeros. This is false. Therefore this block is not executed. Then we move to the else part, and in the else part again we check inside code 1. Inside code 1. Inside code 1. Then let's look at our inside function. Okay, inside function. Here not A, not code 1 means all zeros. Here we have 0 value. When we put not operator, we will return a non-zero value. Therefore, it is true. Okay, true. Therefore, this block will be executed. Okay, this block will be executed. Now swap PTS function will be executed. Okay, now if you look at this, now this part here, this one here, this one here, it was true. Therefore swap PTS function was executed. Swap PTS, yes, swap PTS function. If you look at swap PTS function, okay, so this is our swap PTS function. There what happens, we pass what we do here, swap PTS x comma y. We pass x comma y. That means in our line segment, here we our 0 1, this is our x0, y0, x1, y1. Okay, it is something like this. In order to explain, I will put some values here. Okay, just for an example, not these values. Okay, not these two values, but just I will put some values. Okay, don't mess up with this. Okay, 30, 70, and now inside this function what we do is we swap the coordinates of 2 points, this one to here and this one to here. Okay, then what we do is we declare a double variable TMP. To the TMP we assign the value of x0. x0 means this one 20. Okay, then to x0 we assign the value of x1. To the x0 we assign the value of x1, that means 30. To x0 now we have 30. Okay, then to x1, here to x1 we assign the value of TMP 20. Now to x1 we have assigned 20. Okay, again this line of code to TMP we assign the value of y naught is this one, 40 we assign. Okay, then to y naught we assign the value of y1 in this line of code. Value of y1 is 70 to the y naught, 70. Then again in the last line of code to y1 we assign TMP value 40. Here we assign 40. Okay. Now after execution of swap PTS function, now you can see the coordinates have changed. Now see here 30 and 70 came to here, and 20 and 40 went to here. Okay, that means swap the coordinates of the point. Now that means here 0 means this one actually. Now I have drawn diagram. You have to think. Okay, so now it is no longer this line segment. Okay, now to actually what happens is we have to change the indices. Okay, because coordinate cannot go there. Okay, so we have swapped. Now x0 y0 stores this coordinate, x1 y1 stores this coordinate. Understood? So here actually don't mess up with the way I have drawn the line segment. Okay, actually indices you have to change. After that, so here it comes 1. Here now we have 0. Now what about codes? Now codes, here to the 0 we had code here. So definitely we have to swap the codes as well. Therefore we swap codes. Therefore here code 1, code 2. To the code 1 we have to put 0 0 1 0. To code 2 we have to put 0 swap. We have to swap. Okay. So now those are the new values of code 1 and code 2. After swapping, this one is all zeros. 0 0 1 0. Okay. Now no, sorry. Yes, these are the new, not our previous values. Previous values we have to swap. Now new values are 0 0 1 0 here, and here 0 0 0 code 2. Yes. Now these are the new values after swapping. Okay. Okay. Sorry. And now yes 0. Yes, now here also we can see the same diagram and codes. Code 1 0 0 1 zeros, all zeros. Okay. Now then we yes we yeah this block was executed. Now it comes here. We check the condition x0 not equals x1. This condition is true. X coordinates are different. Therefore, we compute the gradient. Again, we compute the gradient. Y0 minus y1 divide x0 minus x1. In this way, we compute the gradient. Okay, gradient. Then we move to this one, called one bitwise and left edge. Code 1 means 0 0 1 0 bitwise and left edge 0 0 0 1. Okay, so this one we get all zeros. That means condition is false. The condition is false. This block was not executed. Now we come to this part, code 1 right edge. Code 1 means yes, 0 0 1 0 ampersand right edge 0 0 1 0 0 0 1 0. Yes, this one 0 0 1 0. This is true. Okay, this is true. Therefore, this block is executed. Now let's see. Yes, this line, this one is this. Okay, now I will explain. Now here we have this so 1 and 0. Here we have to compute this coordinates of this point. So if you have drawn the x and y axis, okay, so here we have max x, okay, max x coordinate. We have to compute this value. And now as in earlier situation, we just we try to compute the equation y minus y naught, then x minus x naught. Okay, x minus x naught. This equals to m. Okay, this equals to m. M is the gradient. We have already computed the value of this one. Then y naught. This one you can write y naught plus x minus x naught into m. Okay, now we know the x coordinate. We know we substitute x max x value and then compute this one. Okay, then y naught plus max x minus x naught into m. Okay. Now here, since we are using the same variable, we can write this y naught plus max x minus x naught into m. Okay, so this one can be written in abbreviated form like this. And now you know the x coordinate is max x. Therefore, x naught is max x. Okay. And this order is important. This one and this one. This order is important. You have to think. Since we are using the same variables, this line should come before this line. Okay. If you swap the order, then it is incorrect. So you have to think about that. Okay. I am not going to explain. Now, this part, yes. After performing the computation, now our new value x naught y naught, it is here. That means now this one, it is here. It is here. Okay. Now in the diagram I have shown it. Then this part was executed, and else if, okay, therefore these parts will not be executed. It is else. No, this is true. This part was executed. Now this part will not be executed. This part will not be executed. Okay. And again we come to the beginning of the while loop. Okay, again done variable, we have not done anything to done variable, so this is still true. Therefore we come to here, code 1, we invoke the encode function with this one 0, with 0, this coordinates. Okay, and here let's go to our encode function. Initially our code value is initially all zeros, then we move to here x less than min x, no, this is false, x greater than max x. What about this condition? Actually here we assigned to x naught, we assigned max x, if you can remember. Okay, therefore it is not greater than max x, it is equal to max x. Therefore this condition is false. Y less than min y, y coordinate less than min y, this condition is also false. Y greater than max y, this condition is also false. Okay, this condition is also false. Therefore now you can see this condition is false, this line of code is not executed, this is false, therefore this line of code is not executed. This is false. This line of code is not executed. This is false. This line of code is not executed. So nothing happens to this value. Therefore, we return the code 1 as all zeros. Okay, now our code 1 value become all zeros. All zeros. All zeros. Okay, then here code 1 value we come. Now here I have written done this line, then all zeros, this one, this one, this one and this one. So code 1. Again we move to the code 2. Code 2, that means here we invoke the encode function with respect to this one. Okay. Okay, then in order to compute code 2 value. So we have, let's go to encode function. There initially code is, we have all zeros. Okay, then x less than min x, min x, this is false. Okay, x greater than max x, it is false. Y less than min y, false. Y greater than max y, false. Because now if you can remember, in earlier situation we have put y1 to y1 we had put max y. Okay, therefore y, this one is not equal to max y. It is not it is equal to max y, so this condition is false. Now therefore code 2 we have all zeros. Okay, same value we got. Okay, because we did not change this one. Okay, therefore we had got the same value. Okay, now yes, here if I explain this, initially it is 0 and this is false, therefore this line of code was not executed. This is false, therefore this line of code was not executed. This is false, therefore this line of code was not executed. This is false, therefore this line of code was not executed, and we return code as it is, this one. Okay, now that part is over. These two lines are over. Then let's see. Okay, then we move. Yes. Now this part I discussed and this part I have discussed. Then we move to here. This one, accept. Accept function. What is that? So we go to the beginning. Yes, not operator 0 0 0 0 or 0 0 0 0, not all zeros. Now this returns, yes, no, sorry, this returns true. Okay, because now here we have 0, therefore we will return a non-zero value. That means the condition will become true. Okay, condition will become true. Therefore now we set the done variable to 1. Okay, and draw variable to 1. Okay, this block, this condition is true, therefore this block is executed, and else part is not executed. Okay, else part is not executed. Else parts are not executed. Therefore now again here we have set these two variables to 1, and again we move to the beginning of the while loop here. Now again when we check done, this condition is now false because value of done is 1, condition is false, therefore we exit from the while loop. Okay, we exit from the while loop. Exit from the while loop, and we come to here. This condition draw 1. Yes, this condition value of draw is 1. This condition is true. Therefore, we execute this block. Set color 15 means set the color to white. 15 is white in C programming, and then we, yes, this is now true. I will erase this. Okay, now set color, we put a color. Okay, now again we invoke line function round. We use round function. Now here, now you know we have computed intersections. Now when we try to compute, even if the coordinates of initial line segment, even though initial line segment they are integer values, coordinates in initial line segment, even if they are integer values, since we compute intersections, sometimes we might get floating point numbers to the coordinates. Okay, but when you consider the computer screen, here you have pixels and they are integer coordinates. Okay, here the computer screen is a grid of pixels and they have integer coordinates. So therefore these fractional values we have to round them to the nearest integer. That is done by round function. We have already discussed round function. The round x naught, round y naught. Okay, round x naught, round y naught. Round x1 round y1. Okay, in this way we can draw the line segment. Therefore, now this line segment is drawn on the screen. Okay, so now you can understand. Okay, here I have put line segment is drawn. Okay, now I will go back to our example. This was the initial line segment, and then it became like this, and again it became like this. Likewise, we have extracted the part inside the rectangle. Okay, now that is the end of the discussion of Cohen-Sutherland line clipping algorithm. Okay, so if you could understand properly. Now we have discussed Cohen-Sutherland line clipping algorithm. Now I hope I explained it using very simple methods. I hope you could understand. So if you could understand properly, okay, these two documents are available in my academia.edu. Academia. Here, these two files are available. You can search for my name. Okay. Kasunranga Vijayveera, and if you could understand these two properly, then you can like the video and then put a comment. Okay, put a comment, and also you can subscribe the channel. And okay, so finally, thank you for watching the video.